Hello guys, welcome back to Tutoring with Abdul, and today's class will be talking about hexadecimal number system. As we know hex and we know decimal, hex is not English word, but it's a Latin word. It means 6 and decimal means 10, so that whatever that is saying, it is 16 number system. So a number system that has from 0, 1, 2, 3 all the way to 9. Then it starts A, B, C, D, E, F. 9, 10, 11, 12, 13, 14, 15, and 1, 16 right here, 0. So it has 16 symbols there. That's why we call it hexadecimal number. Okay, because we call it hexadecimal because it contains 16 symbols, 16 digits. Okay, so we talked about hexadecimal number. The hexadecimal number is the number system that has 16 symbols. Start from 0 to 9, then A, B, C, all the way to the F. It only has 16 symbols, but we can repeat these numbers like 1, 0 and 1, 1 and keep going on. They will represent other numbers and decimal points too, like a decimal number system. Like 10 will be in hexadecimal will be 16, 11 in hexadecimal will be decimal 17, but I will not confuse you with these. I'll leave it right here. So okay, so the hexadecimal number system is a system that use from 0 to 9, then follow up with A, B, C, D, E, F. So you have the 16 symbols for the hexadecimal system. Or we can say like hexadecimal system is base 16 number. It's used to represent binary number in a computer or digital electronic. It's easier to, the advantage of that is because it's converting 4-bit binary number. Every digit in hexadecimal number is representing 4-bit binary number. For example, 5 in hexadecimal number has a 4-bit binary number representing in the binary number system. So that's what I'm saying right here. The advantage of hexadecimal number is converting directly from 4-bit binary number system. Any number that we see in this flowchart from 0 of this number system from 0 to F, each number is containing 4-bit of binary number. For example, I say like hexadecimal decimal E stands for 4-bit binary number 1110. So this is equivalent to E in binary hexadecimal system. Why do we use hex system? Because we having too many number system. It's very convenient to use a hexadecimal system because it takes what I call smaller space, little space than binary system. Or because so let's say for example B4, we have to if you have a code starting with B4 or any information that says like B4, if you have that data in a binary number, that will be B is 11, so that is your 11 right there, and 4 is this, so you have 8-bit data. Instead of that, we just write 2-bit hexadecimal number, so that will be relatively easy to write it down, so you don't have to just think in your head like, okay, how do I write like B4 in binary? So you have to do a lot of thinking and a lot of number conversion there. So a hexadecimal number is relatively easy for dealing with at least 8 to 12 or 16 bits number too. For 16 bits, I mean like if you have to write down A, B, C, D. So you know A is 10, B is 11, C is 12, D is 13, 10, 11, 12, 13. So that will be 4 digit, 4 bits, 4 bits, 4 bits. So there'll be 8 and 8, 16 bits right there. So that is relatively easy. So that's how I think hexadecimal number came to play a role in digital electronics. So there is a note that I put: having a subscript will make our life so easy. Yes, because only number, let's say, like if I say like 320, what is that? Is base 10, base 2, base 16, base 8? What base is that on? So if we don't have a subscript, if we have that, that makes it, that doesn't exist. Okay, if we have this is different number, if we have a this is different number, if we have this is different number. So we have to see the content of what that is, what the subscript is, and that will make it easy for us to understand what that number code is. Like here, 1110, base 2 is a binary number. 2A3 base 16 or subscript 16 is a hexadecimal number. And 320, I can set the 320 because it's base 10, or so it'll be 320 is decimal number. So the subscript will play a good role in there. Let's move on to this table, the table for binary, decimal, and octal number, hexadecimal number. So this 0 to 15 numbers, this one. And this is a table for decimal, binary numbers, and hexadecimal numbers. So we will see like what is common. 0 to 9 decimal and hexadecimals are equal because they're using the same. 0 to 9 symbols are the same. After that, the hex symbol, like I said, like 6 other more letters will start. 1, 2, 3, 4, 5, 6. The hex plays a role right here. That's your hex part, and that is your decimal parts. So they're kind of up to 9, they're similar because, yes, as I said, like they're using decimal part there, and hexa part is coming from A to F, whereas A is 10 and F is 15. So there's your binary conversion for that too. That will be a good handy table. We might use it in the examples there. So please keep it, or you can take a snap picture of it. Alrighty, so we said like talking about the number system, we often need to convert these number system to one another. So the first thing we will talk about the conversion of hexadecimal to binary. So how we do that? It's easy. It's not hard. So when we convert hexadecimal number to binary, we will convert each hexadecimal, because each hexadecimal number represent 4 bits binary number. For example, A is representing this 1010 binary, and if you have A and C for instance, so A is 1010 and C is 1100. Okay, so that combined together is A and C base 16. So that's what we mean when we say like how to convert this number there. All right, moving on to that example that we just said, like it's easier to do conversion from hexadecimal to binary because we just convert each digit of binary to its each digit of a hexadecimal, I'm sorry, to its binary representation. Let's say convert C4 and A2 and A3 to binary numbers. Before we do that, let me repeat that. When converting hexadecimal to binary numbers, each hex digit is converted to its 4-bit binary number system. So what does that mean? So C is converted to binary number. Whatever the binary representation of C is, we will write that one, and whatever 4 binary representation is for 4, we will write that one as well. Let's let's do examples here, that couple examples that we have. So solution, I said like C is a one hex and 4 is another hexadecimal number. Hex C is equal to 1100, okay, which is A being 10, 11, 12, so C is 12. So if you look at that, that is your 8 and 4, 12, and 4 is 0, 0, 1, 0, 0. Just to recap here a little bit, how we know that's the binary number, because we have a 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So the fourth digit on binary number is 8, this is 4, this is 2, this is 1. So if you have all 1, 1, 1, 1, that will become 15. So 8, 4, 12, 12 and 12, 12 and 2, 14 and 1, 15. So that's how we find out our binary numbers system there. Okay, so how we convert that C4 and A2 and A3 to binary number? We know what is C. C is, we say like 1, 1, 0, 0. So 1, 1, 0, 0 is C. And what is 4 is 1, 0, 1, 0, 0. So you combine them together and that's your C4. Now what about, why does that keep turning to pencil? Now what about A2? So A2 is, so A, we know A is 10. It's again turning to pencil. I don't know why. So A, so A is 10. 1, 0, 1, 0. So that is your A. And 2, it's a little bit frustrating here. 2 is, the binary representation for hex 2 is 0, 0, 1, 0. You combine these together, these two, you get A2 is equal to 1, 0, 1, 0, 0, 1, no, that's 0, 0, 1, 0. So that's your hexadecimal representation. Now we have a A3. We will follow up the same procedure. A is 1, 0, 1, 0. And 3 is actually, what is 3? 3 is 0, 0, 1, 1. That is 2, that is 1, so that will be 3. So 0, 0, 1, 1. So that is your number A3. So A3 is your, that A3 is your hexadecimal, and that's your binary number right there, binary representation. Okay, so that's for that example. Okay, part 2 is converting from binary to hexadecimal number. This is a little bit a memory-based problem here, because we should be able to remember what a binary numbers are from 1 to 10, 1 to 15 at least. To convert those numbers, 0 to 15, I'm sorry, it's like you have to, we should know this thing, otherwise it'll be a little bit challenging to convert binary to hexadecimal. Or we should have our table, that table right there. We should have this table all the time with us to see like what binary number is representing a hexadecimal representation. For example, in this example right here, 1101 and 0010. So 1101, I will just say like, so that will be this guy right there. And the other is 0010. 0010. So you combine them together, so this will be D2. For instance, if we have the table, that'll be easy. So that's how we find it. Or we can just simply remember or memorize, or try to find a way to memorize those binary numbers, so it'll be easier for us to do it. So it's hexadecimal decimal. Since each number has 4 digits, we can look at the table given earlier to convert to hex from binary. Yeah, that's one way, but the other way is to remember what binary numbers are from 0 to 15. And for that you have to categorize, because it's four, we say like it's 4 digit or 4 bits right there. So in your mind you have to separate 4, starting from the right, you separate 4 bits all the time. So you separate this one and this one. So you go okay, so if you separate right here and this one right there, so 1101, if you say like, okay, you start from here, so 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So that's wherever you have 1, you can count that and add it together. So that's 8 times 1 is 8, 2 to the power 2 is 4, 4 times 1 is 4, 8 and 4 is 12. There's nothing in here, but you got 1 right there. So what is that? 12 and 1, 13. For 13 binary number, 13 decimal number, you have D. As we said earlier, 13 is your D right there. Or you can just simply look at the table. Where are we? Okay, so that will be, this is your D. And what is that? 0, 0, 1, 0. That's 2 to the 1. So that is only 2. So that will be your D2. Because we say hexadecimal number from 0 to 9, they're equal to the decimal number. From 10 to 15, they're calling hex numbers. We start from A, B, C, D, E, and F. Okay, so we said solution is we said each hexadecimal number has 4-bit binary equivalent representation. I don't know if that spelling is right, by the way. I'm not good at spelling. Let's find out. 1101 base 2 is D in hexadecimal number. Yes, we found that. And 0010 is 2 in hex number. So yes, then you combine them together, it will become D2 base 16. Okay, that was simple enough, right? You just have to know each 4 bits representation. You can look up the table and see like, okay, what that number is. It'll be easier, the easy way to do it. Other way, you have to convert these numbers in your mind to binary. Then you can convert it to the decimal first. Okay, that is 13 and that is 2. So what is the 13 representation of decimal number in hex? Will be D, and that 0010 is 2 in hexadecimal, and even the decimal number. So that'll be D2 for that. Okay, it says like convert the following numbers to the hexadecimal. Okay, so we have 1, we have 2, we have 3, we have 4 examples here. I think I already did A here. So what I did for this part, I had to find what is that representing in the table. If you look at that table, 1111 is the last digit of being a 4 bits number, because that's the very last number for being a 4-bit number, which is 16. No, I'm sorry, it's 15. Because 2, that's 8, 4, 12, 12 into 14, and 1, 15. So it's 15-bit right there, which is 15. And 15 representation for hex is F. And 0110, that is 2 to the power 2, 2 to the power 1. So 4 and 2 is 6. So that will be what? That is F6. So in my representation, yes, there's F and 6. This is 6 part, and that is F part. F, and that is 6. So the clue is here. So you have to separate each 4 digit and find out from the table what is that representing to the hexadecimal number, and then convert it there. All right, let's solve problem number 2. It says 1 0 1 0 1 0 1 0. So yeah, again you separate them. So see what that is. It seems like a 10 10. I memorized these things. 10 10, it's a decimal 10. For 10 is we have a hexadecimal number. 10 hexadecimal number is A. You can write down base 16, or you don't have to, because A is already there, but if you do, that will be nice. And the other is the same, so that will be A. So for 1010 is A is a hexadecimal number. Okay. Okay, moving on to C. C is 1 1 1 0 1 1 1. All right, we said to solve this thing is we should be able to separate 4 to 4 starting from right, 4 bits first. So we got 4 bits here, but we don't have any 4 bits there, so we can write this one down as 0 1 1 1 0 1 1 1. So that will be our representation for that. Yeah, it's 0 so 0 1 1 1 0 1 1 1. So you can separate them right now. So you just have to do some markup to these numbers because it's missing a bit. So you can add a 0 there because that's what it means, because somebody didn't write a 0 in here, so it's missing a 0. So no worries, you can just give it to that. Okay, so there's how you do it. Yes, as always, we have to find out what from the table what that 0 1 1 1 is to the hex number, and what is the same thing, there's repeated same numbers. So I think it's 8 no, I'm sorry, it's 4 to 4 to 6 6 and 1 7 7 7. So that will be 7. We said earlier from 0 to 9 they are the same as a hexadecimal, and decimal number are the same. So this binary number is representing 7 in decimal number. So if it is representing 7 in decimal numbers, it will be representing 7 in hexadecimal number. So let's check it. I got the answer 7 7 base 16. Let's go to that table. So it was 0 1 1 1 0 1 1 1 twice. It will be 7 and 7 base 16. Alrighty, let's move on to number D. Okay, so D is asking what is 1 0 0 1. 1 0 0 0 1. Again, we said we have to separate from the right how many digits? 4. So you gotta separate it here. Let me write it down. Here, so it'll be, so you separate it there, so it'll be 1 0 0 0 1. You separate it here, so you're missing 3 zeros there. So it'll be 0 0 0 1 0 0 0 1. Then you have to look at the table and find out what is that representing. I think it's 1 in decimal number. The 0 0 0 1 is 1. 0 0 0 1 is 1 2. So that is 11 base 16. So that is 11 base 16, not base 10 here, because 11 and 10 are different. 11 and hexadecimal and 11 and base 16s are base 10s are different. Okay, 11 base 16 is not the same as 11 base 10, so they are different numbers. Alrighty, moving on to our next topic. Okay, converting from hexadecimal to decimal number. So we will do a couple things here. So we have two options: convert hex to binary and then binary to decimals, or convert hex direct to decimals. So it's easy if you remember what is the representation from 0 to 15 in binary number system, and also it will be not a bad idea if you remember what is representing from 0 to 15 in hexadecimal representation. So in this, the first A is saying like convert hex to binary and then binary to decimals, which is not that hard, but it takes 2 steps. Or convert directly to hex to decimals. Okay, let's do example on both of it. For example, convert 2CB base 16 to decimals. Solution. So we know 2 and it's a hex. 2 has a hex. These are all hex number. Base 16. Base 16. 2 is 0010 and binary. C is what is C? C is 12. C is 12 in decimal, and C is base 16. Base 16, C is equal to 1100 as a binary number, and B is 11. So that is 8 and 2 10 and 1 11. So how we do that? So now we got you write these numbers. 2, that is your 2, that is your that's your 2, that's your C, and that's your B. So 2CB is that number. If you want to convert it to binary first, that's how you do it. There we go. Then you convert these numbers to its decimal values, and you have to find the placing value for that. Okay, so we have 12 digits right there. So 1 2 3 4 5 6 7 8 9 10 11 12. So how you convert that to decimal number, binary to decimal? You have to find the placing value of that. Start from the right and go all the way to the left, and that will be representing your bits, number of the bits. Then you write down each number on each number below the placing value. So wherever you see 1, you multiply that by the number representing here. For example, this multiply by that, this multiply by that, this multiply by that is 0. 0 doesn't count, so that's why we don't add 0 there. So we got 1 in 512, so it'll be 1 time 512 is 512. And we got 1 right there, 128. We got in 64, so all the way to here. So the 715 is our decimal number. Okay, so that's a long way to do it. You can convert the number first to binary system, then after that you have to do a placing value and go to the decimal number system. It's kind of tricky though. It takes 2 steps, but let's see if we can do that direct approach. Okay, so the B is a direct way. So for that, we should have one thing in mind, because since we are dealing with a hexadecimal number, and hexadecimal means 16, so you can always say like time 1x or 116x or 256x, whatever you like it. I put s there just to not confuse me there. So you can put x time, or it'll be personal choices there, but as far as you know it, that's the deal. So we have 2CB. So we're starting from 1S. We start from the very right. That's how we do our placing value. We will do the placing value for the hexadecimal number. To convert it to decimal number, we will write down those 3 letters first, then we will place those values. So that's the first one is 1S. Then you multiply that by 16, you get the 16S. Then you multiply that by 16, you get 256S. 16 times 16 is 256, and I believe so. Let's check it. 16 square. Oh, that's something else. 16 square. 256, yes. So that is your third place value. The first place, second place, third place right there. So what do you have to do after that? If you find the placing value, then this number, that means 2 is multiplied by 256. C, what is the value of C? It's 12. 12 multiplied by 16. And what is B? B is 11. 11 multiplied by 1. This number you see, this is your multiplicand, and this is your multiplier. Okay, these are your multipliers. So that's how you should know these things. You shouldn't have any problem with it, but that's how, if you find a placing value, you just place the values there. 1s, and since we're dealing with a hexadecimal number, the second place will be 1 times 16 will be 16s. The third place will be 16 times 16 will be 256s. So there is a multiplication sign right here, so because this thing will be multiplying to this placing value. So 2 times 256 is 512. C is 12. 12 times 16 is 192. And 1 times 11, B is 11, will be 11. So you add all these numbers, you'll get 715 base 10. And that's how it works. It's when the direct approach. Okay, this is just for this multiplication was just for your convenience there, so you know what that means. Okay, let's do a couple more examples. We will clear this concept out. Okay, find the decimal values of 2DCE and 33EF. Okay, I think I have done this example here, but before I go to that example, what you have to do, you just have to find the placing value. So it will be 1s. The second one will be 1 times 16 is 16s. The third one is 256x. S. And that times 16 will make it 4096s. Now you place each value there. I have to do it for each example separately. So 2 is becoming, because it starts from the right to the left, I have to follow my way. E, C, D, 2. Now, once you get that part done, the next part is just a multiplication. Whatever letter is there, you have to multiply that by the placing value. So there'll be 2 multiplied by 4096. What is the value for D? A is being 10, B is 11, C is 12, D is 13. So it'll be 13 times 256. And C as before D is C, so it'll be 12 times 16. And what is E? E is 14. So 14 times 1. I know that from my head, that's 14. Now, what is 12 times 16? 12 times 16. 12 times 16, not 13, will be 192. I should know that because I had that in the earlier example. And 13 times 256. I'm punching numbers in my calculator. 3,328. And that, what is that? 2 times 6 is 12. 2 times 4 is 8, and 1 9. It'll be 0. 2 will be 8,092. Then you add these numbers together and see what you get. 8,092 plus 3,328 plus 192 plus 14. So I got 11,626. 11,626 base 10. That is the direct approach by placing values. You have a indirect approach, so that means you have to convert each digit to the binary representation. Then from binary you have to have a placing value, and then do it from binary to decimal. So imagine that you have a 4 4 4 4. You have 16 bits of binary numbers, so you have to go to 2 to the 15 power. That will be a little bit tricky to do that way, so it'll be easy to do it with a hexadecimal representation, direct approach. So that's how will help you guys there. Okay, moving on to the next example. Okay, before I go to the next example, I found an issue there in my multiplication. This doesn't seem right. Let's correct this mistake. 2 times 6 is 12. 1 will go right there. 2 times 4 is 8. 2 times 4 is 8. Is that 8? That's not 4. That's how I got messed up. That's 9. 2 times 9 is 18 and 1 9. 2 times 9 is 18 and 1 19. 1 go there. 2 times 0 is 0 and 1 will be. This is not 0. This is actually This is actually a 1. So 8,192. So that will leave me with one extra 100. So it will be 11,726 base 10. So yes, simple mistake will mess you up, so be careful with that, guys. Because I thought, like, I wrote this down, I thought it was 46, but it was 96 actually. The only reason I got it correct because I was double checking those numbers in calculator, and I said, like, yep, that's not right. So I did something, and there was this multiplication. I thought of this one, the way I wrote it, it would look like 4 to me. So 4046 times 2 was a different number, then 4096 times 2 is a different number. All right, moving on to the next example. I already solved this example for you guys. There we are. This is the right way to do it because I already had it correct when I did it before the lecture. So yeah, mistake happens. So moving on to the second part of that example was 33EF. So 33 was B, 33EF. I wanted to give it to you guys, this example, but let's do it together. Okay, before I distract you guys with another topic, let's go. Since we have 4 digits, we will be 1S, 16S, 256S, and 4096S. We just multiply 1 by 16, 16 by 16, 16 by 256 by 16. That's how we get these numbers. Okay, now this is 3. Because since we got these from 4, we can write it from left side to the right. Or you can just always do from right to left. E, F, E, 3, and 3. Okay, so what does that mean? These are the multiplication process. Now, whatever number you have to multiply by that placing value. So that will be 3 times 4096. 3 times 4 be 3 times 4096. I hope I don't mess it up again. It will be 12,288 plus. So you have a 3 times 256. This is S actually. 3 times 256 will give me 768. 768. 3 times 6 is 18. 1 will go there. 3 times 5 is 15 in 1, 6. 3 times 2 is 6. 6 in 1, 7. Alright, now add this number. E is 14. 14 times 16 be 14 times 16. 14 times 16 will give you 224 plus F is 15. 15 times 1, I know that is 15. So let's add them all together, see what number we get. 768, 12,288. I got 13,295 base 10. Imagine that number writing in a code versus only 33EF is relatively very easy numbers to write it down as a hexadecimal number will make your life easier. Okay, so it's enough from the example. Let's see what we got. 13,295. Yes, that's the correct answer. I got the same answer from my programming calculator, so that adds up. So I was saying, writing this number versus 13,295 in coding language, it'll be a little bit tricky because 4-digit number, it's relatively easy to memorize this 33EF because there's nothing complication. This is not a huge number, 2 decimal, but what if you had it like a decimal number? I mean, I'm sorry, like a binary number. For 3 binary is 0, 0 1 1 0 0 1 1. That's 3 and 3. And E is what is that? E is 14. Yes, so that will be 1 1 1 0, and F is 15. There will be 1 1 1 1. So that is representation of the binary number representing 33EF. That is a 16 bits number. So that kind of be a little bit hard to remember or memorize these things. That's how we, and that's why it's easy and useful to use hexadecimal number there. Okay guys, it's enough from these example. I hope you guys learned something. Let's move on to the next topic. Alrighty guys, the last topic of the hexadecimal number system is converting decimal numbers to the hexadecimal number. It shouldn't be that hard because we already dealt with the same kind of process before. When we if we remember, we tried to convert decimal to binary. We divided that number by 2. We do the same thing, but here is our divisor is 16 because base 16, but follow the same rules. So we will divide that number by 16. Whatever whole number we get, that will be our new quotient, and that quotient will be divided by the 16 again. But if at each step, if we get a remainder, we will bring that down and write that as a hexadecimal number. For instance, here 55 is a decimal number. It's asked to write this as a hexadecimal number. So what we have to do, divide 55 by 16. So if divide 55 by 16, you get 3 because that's 48. 3 times 16 is 48. Then you get 7 as a remainder, and you bring that down right here. So that 7 is down. Now then we have a 3 as a quotient was there. So 3 divided by 16, it's nothing we can do that there. So it'll be 0. What is remainder is 3. So 3, 7, base 16 is our hexadecimal number. So 37. So 55 base 10 is equal to 37 base 16. Okay, so hope that's clear. So what we have to do, we divide that number, the decimal number, by 16. We get the quotient. We don't touch the quotient, and then see the remainder. We will bring that remainder. If we have any remainder, we'll bring that down. If you don't have anything that we have it, we've got to bring it down. If it's even 0, you have to bring it down. And then 3 divided by 16 is 0, and the remainder is 3 because we couldn't divide 3 by 16, so we bring that 3 down right there. Alrighty, let's do find the hex values of the following numbers. 301, I'll do 2 of them, and I'll leave you guys with 2. I'll give you the answer for these 2, the one that I'm not doing, and I'll give you guys as a homework. Please let me know if you have any question or concern about this thing. Alright, let's shift gears and do which one I have to do. I'll do the easy one. You guys do the hard one. So A is 30A. 301 is base 10. All of them are base 10. They're all decimal. And how we find it? Yes, we said like we have to divide 301 divided by 16. 301 divided by 16. What we get is our quotient. We get 18 full number. 18 times 16. 18. So what is the remainder? Let's see. Remainder is 13. Remainder is 13. What is 13 for hexadecimal number? It is what? 13 hex is D. So we will bring D down. Alright, now the new quotient was 18. we got 18 divided by 16. We get 1. Remainder is 2. You bring that 2 down. Okay, so the new quotient is 1 divided by 16. The answer is 0 because in hexadecimal it's not possible, and the remainder will be 1, and then we bring that 1 also down. So 1 2D, so 301 base 10 or decimal number is equal to 1 2D base 16. Okay, so that was part A. Let's solve a. Let me do B. So B is 4050 base 10. Convert that to hexadecimal number. It says no 4000. It's asking to find the value hexadecimal. Yeah, so these are decimal. We gotta find the hexadecimal number. So 450 divided by 16. 450 divided by 16, what we get? Okay, you get 253 as a full quotient, and the remainder is the remainder is 2. Remainder is 2. You bring that down. Okay, now we got a quotient of 253. Divide that by 16. 253 divided by 16. You get 15 times. So your remainder is 13. 15 times 16 is 240, and that's 53 was divided, so we got 13. You got 13 down. For 13 we had a equivalent hexadecimal number is D. Now we have 15 divided by 16. It's 0, not possible here in hexadecimal number. The remainder will be 15, and 15 is F in hexadecimal number. So the answer here is FD2. So 4050 base 10 is equal to FD2 base 16. Okay, so 4050 is FD2 is base 16. So that's how we get it. Alrighty, you guys solve C and D. So C and D is your homework. For C, the answer for C, and for D, I'll give you these two answers, and you guys just have to find the value. For C is 78. What is D? D is 130. And for D is 82. But find it. Alright, until then guys, I'll see you, and please be careful and try to do practice with the binary and hexadecimal conversion. We'll talk about these later, and don't stress it out. It's not that hard. It's just a conversion. It just requires some math skills.